Okay, I will then share my screen. Can you see it? No. Okay, can you see it?
Yes. Thank you.
Very good. Okay, thank you, Judith, very much for your very kind introduction. And as usual, it's always so good to see you, although digitally. Thank you to everyone for attending this seminar. So the presentation that I'm about to deliver is about part of my doctoral thesis that, as Judith said correctly, was carried out in Portugal. But I also wanted to briefly introduce myself, even if Judith already did it amazingly. And as she said correctly, my background is both in conservation of graphic documents and conservation science. And I did my education in Italy and partly in Portugal, only my PhD. My research interests, as she said correctly, are all related to several analytical techniques related to conservation science and most generally the characterization of the artistic practices for painted artifacts. Also, my current affiliation is as a postdoctoral research fellow for this Portuguese project, Books, Rituals and Space in a Cistercian Nunnery. More specifically, this research project that I would like to present also because it allows me to be here and to speak with you is an interdisciplinary and interinstitutional project that is interested into the reading, living, and devotional practices that were maintained by a feminine order based in Hardouyn. More specifically, in this Portuguese monastery, there was a feminine order, and as part of the team, we are interested in the characterization of the materials of illumination. I said before that this project is interinstitutional because it gathers expertise from several research institutions. And the one that is to which I'm currently affiliated is the University of Évora. This university is located in the center of Portugal, in the region of Alentejo, and is one of the oldest, maybe either the first or the second oldest university of the Portuguese territory, which has been founded in 1559. Ever since then, this university gathered several expertises, and nowadays is one of the main universities of Portugal, which also hosts several research units. And the Hercules Laboratory is one of those. Hercules Laboratory, that is my main affiliation, is a laboratory devoted exclusively to the study and preservation of the cultural heritage, as it is expressed by its own name. Indeed, Hercules is an abbreviation for Herança Cultural, Estudos e Salvaguarda, which from Portuguese translates to cultural heritage, study, and conservation. And this laboratory has been active ever since 2009. During this almost 2 decades and a few years, the Hercules Laboratory was able to gather a very vast analytical set of analytical techniques for the macroelemental, macromolecular, biodegradation, biotechnological, organic, material characterization, and it also has several optical techniques and several mobile instruments. Hercules Laboratory is a research institution that coordinates several projects of research and development and an equally numerous number of projects on which it is partner, both in Portugal but also abroad. Among the most important projects that Hercules coordinates, there is also HERIS. For Portugal, of course, there is HERIS, which is the European Research Infrastructure of Heritage Science. This is an European platform that gathers several academic and non-academic institutions which are involved in the study and conservation of the cultural heritage by using the methods of heritage science. And as for the Hercules Laboratory, what it does is the coordination of the Portuguese section, and also it carries out most of its mobile laboratory activities from this MOLAB. So, but enough with the presentation. Now I will go in depth into the topic of this afternoon, which as I said before, is only part of my doctoral thesis that was devoted to characterize with more things. But all my thesis was related to the study of a production of books. And more specifically, this production took place in Paris in the first half of the 16th century. For those of you that maybe have seen typography only from their high school studies or only afterwards, the Western printing method was elaborated by a German goldsmith, Johannes Gutenberg, who in 1452 he crafted an innovative method for printing, which involved movable types and a specific information. I say that he devised a Western a type of printing process because actually he wasn't the one that created the printing process by itself, because it has been created by in China already a millennium before. And also there were other printing methods which were available before Gutenberg elaborated his printing press. So the true innovation that introduced in the mid of the 15th century was the fact that he was able to craft a kind of matrix that was changeable. Indeed, by devising these types or individual fonts, he was able to produce a method to have an virtually endless number combination, and also most importantly, he was able to formulate an ink that was apt for being used with these interchangeable types. And ever since 1452, this technology spread very rapidly in Europe. And France was one of the countries that saw its rooting at this period. Indeed, already in the 1470, the first press was set in Paris upon invitation of 3 German printers by the hand of the rector of the university and the main librarian. So this first press, which was housed in the Sorbonne College, was active for 5 years. And in the next decade, also more workshops were opened by other German printers, which were equally attracted to the city, or also by other French printers, which decided to convert to this new technology. And it was already from the mid of the 80s until the 1530s that these workshops were so rooted and became so important that they were able to develop also internal division of the tasks. And also they were able to develop different kinds of activities in such a way that some activities were exclusively devoted to the editing process. Other activities were exclusively devoted to the printing process, while there were even other enterprises which did the editing and printing in the same place. The Hardouyn workshop took place in the third of those phases. Namely, we are already in the phase when they are the largest enterprises. The period of activity of the Hardouyn can be divided into 5 stages. It is called the Hardouyn's workshop because their fame is related to 2 brothers, Gillet and Germain. The activity was started in the last decade of the 15th century by the hand of Gillet. Gillet decided to launch a bookshop that was devoted exclusively to the retail of a kind of devotional book, the Book of Hours. I say that it's only retail. He was only retailing books, but not producing, because Gillet was outsourcing the actual production of those books to other local printers. It was only starting from the second decade of the 16th century that Gillet decided to install his own printing press, and he continued issuing and printing books until his death, which occurred in 1521. So, starting from this point on, Gillet also continued his initial strategy to produce exclusively printed book of hours. And after his death, the second brother, Germain, took the lead, but he didn't take full stewardship of the activity of the enterprise after his brother's death. And indeed, for a short period, he decided to create a collaboration with a local bookseller. It was only starting from 1525 that he took the full ownership of the enterprise, and he continued issuing and he continued producing books of hours until his death and slightly beyond. Indeed, in the following decade from his death, his widow and his son continued producing some books of ours. This introduction was to understand a couple of things. First, that the incunabula production was a successful business by the time the Hardouyn started the enterprise, and also kept on producing books of ours. And this is important because already from the mid, there is a huge visual difference from the books which were produced in the mid 70s, as the one that is visible here in the slide, from those that were produced already by the time they started their activity, which is already in the late, which is in the 90s. So the difference is in the fact that printed books did not only include texts, but they were also starting including some images, as you can see, and as you can see here. The second important fact is that the Hardouyn workshop was quite active. So we are talking about a huge amount of editions, and also an even possibly higher number of copies within each edition. Indeed, the incunabula short title catalog, which is done by the British Library, listed only 7 editions by the workshop. But another important catalog, the BP16 by the National Library of France, lists as more than 200 editions, a good part of which has been done by Germain Hardouyn, and the other has been done by his brother. The third important fact from this introduction is actually that very few technical studies have been carried out before to understand what were the materials of those inks for printing. Incredible, even if the printed objects were studied enormously from a social point of view. And indeed, it was possible only to find a very limited amount of studies, which are all those that are summarized here in this slide. And even so, those studies focus more on the composition of the German inks. And only one case, that you can see the Italian chiaroscuro woodcut, they were interested in the composition of Italian inks, and also not for textual printing. So this means that there was no previous research as for the inks for printing as used in Paris. And also, I wanted to target exactly this shortage by studying a well-established enterprise as the one of the Hardouyn. And bearing this in mind. So, but before continuing, I would like to explain what's a bit an ink. An ink is essentially a pictorial formulation that is done to impart color to surfaces, meaning that it should embed some color material, and also it should adhere to a desired surface for printing. And it should ensure a desired aesthetic effects, meaning being more glossy, less glossy, more rough, matte, thick, thin, and also should be compatible with the spread into and as well as substrate. Meaning, one thing is formulating one ink that has to be spread by a brush, and another thing is an ink that should be offset from a matrix, as well as the substrate, because we could have also substrate that are made of wood, metal, and one thing is having an ink that is made that is waterborne, meaning that you have the main solvent uses water, or another ink that uses another material. And also, it should be durable over time, so it should be degradable. And taking all these things in account, so I decided to focus my research on understanding what is the color material or the pigment used in inks in the printing inks, what is the carrier or vehicle, namely which is the substance that embeds them and ensures their adhesion to a substrate for printing. What are the fillers or materials that are given to achieve the particular aesthetic effects? And also, what are the dryers or catalyzers of the so-called curing reactions? Curing is a general term that is given to identify the cross-linking reactions that occur in the binders that are specifically used in printing, because we don't have curing reactions in other kinds of inks. And also, of course, the support for printing. And in this case, the support was parchment for the advanced books of ours. So bearing in mind this objective, which is researching into the composition of the inks as applied by the Hardouyn's workshop. So this main objective was broken down into 4 main parts. First of which is identifying some possible case studies, then performing their material characterization, all of this work, and also comparing the data that were obtained by the characterization of the case studies with the instruction found from historical treatises, specifically devoted to printing. And also it was important to understand what was the technological purpose of each of those ingredients. As for the case studies, unfortunately, it was not possible to obtain a large set of books. So our study has to be narrowed down to possible cases. And also in those cases, only very limited amount of samples could have been used. One of the chosen books belongs to, both books belong to the phase of activity of Germain Hardouyn. One is more at the beginning of this new phase, and the other is more towards the end. And one book comes from the public library of Évora, that is the city where I am. And the other book is part of the collection of the National Library of Portugal in Lisbon. Both books were microsampled, and the microsamples were analyzed with a set of elemental and molecular techniques. And also those data were, as said before, were compared to technical text for printing, which ranged from the 14th until the 17th century. Of course, the initial goal was to try to search for some technical texts which were specific for the French production of the 16th century. However, it became immediately apparent that such a text and such a very well-defined scope was not possible to achieve. So we decided to extend, to stretch a bit the chronological range from the 14th to the 17th century, and also include other texts that were not only specifically from France, but generally from the Central to the Southern Europe. And then we compared and then we studied, we compared those materials to the known technological effects with modern studies. So as for the pigments, they were studied with one elemental technique and one molecular technique. The elemental technique is scanning electron microscopy coupled to energy dispersed spectroscopy. And the molecular technique is micro Fourier transform infrared spectroscopy in transmission mode. As for the scanning electron micrographs, so we were able to analyze several microsamples from the text, and only one microsample for the ink of the use for the illustration, but only for the book from Évora, that is the one that you can see now on the left. While analyzing the micrographs of these 2 microsamples, they looked only slightly different, in the sense that the one on the left, namely the one from Évora, showed very large and big crystals, while the one on the right showed a more disordered morphology. But the point that they had both in common was in the quasi-globular accretions, and the fact that none of them was showing some spherical structure, both at a microscopic or nanoscopic level, which are usually the clues for the presence of some organic material that has undergone a process of combustion. While in the last sample, for the ink of the illustration from the book of the Public Library of Évora, there was this microsample had an amorphous triangular, showed some amorphous triangular crystals, and in this case, bingo, we actually found these nanospherical particles. So the first indication was that we had materials, we are microsamples of 2 different nature, both all carbon-based, but the ink of the text seemed to be made with some inorganic allotrope of carbon, probably allotrope of carbon, while the other was using an organic or material or of organic origin. Then we use we also analyzed their elemental profile with energy dispersed spectroscopy. And we were able to see that the profile of the elements of the inks of the text, the two microsamples for the ink of the text were somehow comparable. And while the one of the illustration was showing relatively high amount of phosphorus. So the first case, it was possible that the carbon-based pigment could be graphite. While for the illustration, the further presence in the micro-FTIR spectrum of a band, that is of the stretching modes of the phosphate, allowed to identify the hydroxyapatite. Hydroxyapatite is the inner mineral component of both. So this means that the probability of both. So this fact, together with the very specific microstructure of the microsamples, were compatible with a bond pack. So now we go to analysis of the binders, which was done with two elementary molecular techniques. One is the micro-FTIR spectroscopy, again, transmission mode. And the second technique is pyrolysis and gas chromatography coupled to mass spectrometry. As for the micro-FTIR results, both the two samples for the ink of the text show the presence of several stretching and bending modes of the methyl and methylanic group, as well as some the stretching modes of carboxyl groups, and also stretching modes of the hydroxyl. Altogether, all those bands are typical of fatty binders. And also, later we wanted to understand what kind of fatty binder, meaning an oil, would have been used. So, and we were able to understand it by the use of pyrolysis. Pyrolysis coupled to gas chromatography and mass spectrometry. So those results means the presence of three main fatty acids: palmitic acid, stearic acid, and oleic acid, which are indeed typical of oil binders. And also through the ratios, we were able to understand what was the exact kind of oil, or at least to form an hypothesis about what kind of oil was used. As for the identification of the exact kind of oil, usually we can use the ratio between the palmitic and stearic acids, which are two fatty acids, two unsaturated fatty acids. And because they are saturated, they do not participate to the curing reactions. And this is why they are a clue of the possible kind of oil which was applied. While the ratio between the oleic and stearic acid can give us a notion about the aging of this medium. And when it's relatively low, meaning in those ranges that are in the slide, it means that the oil is quite aged. But our sample actually was having a relatively high amount, which is not compatible with linseed oil, which is the most common drying oil used. But indeed, is that these values are typical of walnut oil altogether, both the ratio of the palmitics to stearic acids and the ratio between the oleic and stearic acids. And walnut oil is known to polymerize less than linseed oil, and this is the reason why it was a further indicator of the possible presence of walnut oil. Then we go to the filler, which was characterized again with the same two molecular techniques. As for the micro-FTIR results, those that are in gray are the bands that were used before for the characterization of the binder, so that you don't forget them. But as for the filler, there were several bands related to the stretching and bending modes of carbonates in both samples. And also there was an additional band which corresponded to the combination band of the symmetric and asymmetric stretching modes of the carbonate. So there was possibly a carbonate, and then we wanted to understand if it was calcite, one of the most common. If you remember from before, in the semi-DS analysis that I showed of those microsamples, calcium was present in all cases. So meaning that this very high amount of calcium could be related to the carbonate. So, and calcite becomes a very likely possibility for the filler. Then we go to the last ingredient, which is the dryer. This analysis was done with only with elementary techniques, meaning scanning electron microscopy coupled to energy dispersive spectroscopy and handheld energy dispersive X-ray fluorescence spectrometry. The semi-DS analysis, for the semi-DS analysis, we don't not go through the entire data set, but we want to focus only on two particular elements, meaning copper and lead. Because copper and lead were generally studied to be, were generally seen to be used as secondary dryers of oils. So we wanted to understand if they were present and also at which amount. And we noticed that copper was present in all cases, while lead was present only in the microsample picked from from one image, but it was not present in any microsample of the ink from the text. Now we wanted to compare this information from the microsample. The microsample, of course, is representative only about a small portion of material, with a portable technique, which we could apply on multiple areas of the two books. And for the semi-quantification, we also established a collaboration with the University of Sassari, and we used the results from the portable XRF spectroscopy, and we coupled them to Monte Carlo simulation to perform Monte Carlo simulations to perform some kind of semi-quantification. And we were able to observe that the results, even if they were not exactly the same as the microsample, they showed the same fact that lead was present in the ink of the image, while and copper was always present as well. We were not able to use the same approach also on the other books, but only from a qualitative point of view, we were able to see that in the book, in the microsamples of the text, lead was always absent, while in the was always absent. So now we go to the part of the comparison of those results with the instructions from technical treatises. So of course, the number of treatises were very, very, very few. Because during the research work, I could encounter the fact that printers did not have the custom of registering the information that they had. And actually, the formulation of the inks for printing stayed usually as a secret of each workshop. And the first attempt or the first the habit of starting writing treatises is actually very late, and it dates from the mid of the 16th century until the next century. And this is the reason why I also included very late sources, like the one of Baldinocci, that was written in 1681. So the list of material that they were describing as the binder, the pigment, and possible additives was very varied. But as for the binder, it was possible to see that drying oils and liquid varnish were the most frequent ingredient that was mentioned. While as for the pigment, they were mostly carbon-based black pigments. The additives were either more oil or other materials like natural gum. Also, this recipes was actually quite odd compared to the other. We notice that the additive could be either liquid varnish for the linseed-based inks, or an oil, drying oil, if liquid varnish was used as the main binder. So then we compared those results with the data that was obtained by the characterization of the case studies, and we were able to see that the presence of the carbon black materials was consistent with the trend of the recipes. Very interesting was actually the one recipe from Baldinocci. Indeed, in this recipe that is here labeled, he was saying that walnut oil was typical of French printing. And indeed, walnut oil was the kind of oil that was possibly used for the microsample analyzed from the microsample from the Book of Hours from Lisbon. However, no indication was given as for nor for the dryer nor for further additives. And somehow the study was able to to show some compatibilities some compatibility with the materials described for French printing. As for the hypothesis about the four pigments, took into account the opacity, power of oil, and expanse. So the power of oil is the amount of oil that is necessary to fully embed the pigment. The opacity is related to a number of parameters. However, the refractivity index for the visible range is one of the main indicators. So the higher the difference between the refractive index of the medium and the pigment, the more high should be the power. And also the power of oil is also related to the crystal shape, to the crystal size and shape of the pigments. Of course, this is a very rough approximation because this is a topic for which I can we could do maybe 3,000 seminars, and unfortunately the time is limited. Usually larger sized crystals, they tend to need less oil. While so if we compare to graphite, that was like not fully crystalline, but also it has some good degree of crystallinity, and compared to the ivory black. So the graphite, since it was like that huger crystals, would require less oil compared to the bone black, which was having, if you remember, the very small spherical nanostructures. And so this means that the two pigments were used they require different amount of oil. So in case of the graphite has a higher refractive index compared to the bone black, so it's more opaque and it requires less oil. Whereas the bone black requires more oil, but is more transparent, so you need more pigment. And then it goes that maybe the expanse could be one factor to use more or less pigment between among the two. Also, it's not clear which one was more expensive back then. As for the binder, drying oils were used most of all for their viscosity, which ensures very well-defined images, and also because you have a non-water-based solvent that can be safely spread on a matrix, either of wood or metal, in order to be transferred later to the support for printing. As for the filler, calcite is known to have a relatively low refractive index, so it doesn't affect the optical properties of the mixture, and also it doesn't require as much oil, which are two reasons due to which calcite was generally used in several artistic techniques to improve thickness or to control the roughness and glossiness of pictorial films. As for the dryer, the presence of lead could lead to favor a higher rate of polymerization, also because bone blacks may dry in longer times compared to graphite-based mixtures. In conclusion, the seminar that I presented was about one small characterization of the inks used in textual and figurative printing by the Hardouyn printing within the books produced by the Hardouyn workshop, more specifically by Germaine Hardouyn. And also the research methodology which was applied was multidisciplinary, crossing the methods of material science and also some art technical analysis. And the findings which this study was able to yield was that different formulations may have been used for different purposes, whereas the differences between the formulations arise in the type, mostly in the type of pigment added and the amount of dryer which was added to the formulations. So here we are in the end, and I would like to thank you very much for your attention, and that's it.
Okay, so does anyone have a question for Silvia? Or online, if there are any questions for Silvia? Let me check the chat. Okay, are there any questions? I don't know if it would be better to...
I don't, yeah.
Just a moment, Silvia.
I don't go over it?
Yes, please. There are no
Sorry.
If you don't mind, I will just put the headphones whenever you need to ask a question, because here is very noisy. And whenever I want to reply, I will just unplug it. Okay, so it will take just a few seconds between the question and the answer. Don't you mind?
Yeah, it's okay.
Okay, thank you very much.
Do I like speak into anything specifically, or?
No.
Oh, just I guess one of the questions I had was, like I noted that you said like walnut oil was specific to the Parisian workshops. Can you hear me?
Now we cannot hear you.
That's true. Yes.
Yeah, that's true. And then at the beginning of your talk, there were only a few like previous studies that looked at different workshops. Can you comment more on like the materials used between the different workshops, like between Paris and like Italy and Germany, that you might have observed beyond like the walnut oil?
Well, the technical studies that, no, thank you very much for the question, is actually a very good one. So the kind of materials that, the kind of studies that have been done were, as I said before, about the inks for printing, textual printing, and only in one case for figurative printing. So comparative studies between the two different kind of formulations was not done previously. So this is a first thing. And also most of the studies that were done, so at least 3 of those, actually, no, the great majority of those they showed only, one was investigating the inks from a molecular point of view. Because what these previous studies were doing were reconstructing the elemental profile of those inks. And unfortunately, the elemental profile can give information, yes, also about in a limited way about the pigments that were used. But those studies were more focused on the dryers in order to understand if there were some metals used for a possible curing action, but they were actually not interested in understanding what kind of binder was used. The binder was characterized only by one study by Federica, by the group of Federica Pozzi in the Metropolitan Museum in New York, and they also found some drying oil, but they did not use gas chromatography. They wanted to be less destructive. So they also supposed the presence of a drying oil, so they did not specify which one to be used. But they were supportive in the fact, they also consistent. So my research was consistent with their hypothesis on the use of a drying oil as for the binder. And as for the pigment, they were not specific. But as for the dryer, the differences that arose between my study and especially the study of the German prints was that at the beginning of the typography, they could observe, especially in in those books which were printed directly by Gutenberg, they could find very high amount of lead. And whereas in my case, I could not find much lead, which was a true oddity. And copper was present in all cases. This and also the double presence of both lead and copper was used as a reference to identify, to create clusters of production among German printers. So this was another thing that was consistent with the previous researchers, but which focused mostly on German. So it's also possible, it will be very interesting to do a large-scale study to understand what is the composition of the inks used by the early printers, especially those that were invited directly from Germany and other Parisian print inks. In order to just understand if they also imported their own recipes and if they could use similar materials to before or not. But unfortunately, I couldn't answer this question.
Thank you.
Sounds like a nice project.
Are there any other questions here in the room?
I might take one, but
I do need to come. Sorry. Another question, but they are going to approach because I think the mic is over here.
Yeah, but can you change the camera because I can see only everyone from behind.
Oh.
Yeah,
Can you hear me, Silvia?
yeah, I can hear you very
Okay,
well.
great.
Thank you.
So this question is probably going to betray some naivety, but I know there are different types of paper. So is there any relationship between the content of ink or the components of ink and the type of paper it's being printed on? Or is there any research into that?
No, actually, and also those books were not printed on paper, but they were printed on parchment.
Mm.
So the kind of material can be very different because the amount of pressure that you need to apply to push the ink through the fibers of collagen is different from the amount of pressure that you need to apply to push the ink through the paper fibers, especially cotton paper. So it would be interesting, again, to compare those results to paper, but for the moment, I cannot answer this actually very interesting question.
Fair enough. Thank you.
Yeah, you're welcome.
Probably there is another question.
Okay, okay.
Let me see. Any other questions, or are there any in the chat? Probably. No. Okay. So again, I want to say thank you so much, and even that you are here online, but I wanted to say welcome to Leicester.
Yeah, it was very unfortunate I couldn't be there, but I'm very optimistic that chances will not lack in the future.
Yeah, let's hope so. This happened because of Brexit, but sorry.
Yeah.
Less said about that.
Okay. Thank you so much, Silvia. I will stay with you for a moment, but
Thank you very much.
So I'm going to shut something up, but thank you. I'm going to close